Hello good people. Previously I spoke about the four fundamental forces. I mentioned how the electromagnetic or the electrostatic force is the one that governs most interactions in chemistry. In this video I'm going to talk about the electrostatic forces or interactions at play within ionic and covalent compounds. I'm going to start with the ionic compounds on the left side of the screen. Recall that ionic compounds, although overall neutral, consist of a positive cation and a negative anion. For example, a sodium atom may lose an electron and become a positively charged sodium cation. A chlorine atom, on the other hand, may gain an electron and become a negatively charged chloride anion. I'm going to represent the cation as a purple sphere, and the anion will be represented as this green sphere. Due to the electrostatic force, the opposite charges will attract, and the positively charged cation will be attracted to the negatively charged anion. In this case, that will result in sodium chloride. So, it is the attractive electrostatic force that keeps the ionic compounds together. Opposite charges attract. In case of covalent compounds, things are a bit more complex. Let's look at that complexity on the right side of the screen. I'm going to use molecular hydrogen, H2, as an example. Recall that a covalent bond is represented by a line, which in turn stands for a sharing of two electrons. In order to hopefully illustrate the electrostatic forces at play, I'm going to draw this molecule somewhat differently. A nucleus of any atom is composed of neutrons and protons. Neutrons are neutral, while the protons are positive. So we can think of the nuclei as overall positive. In case of hydrogen, the nucleus is in fact just a single proton. I'm going to represent the nuclei of the two hydrogen atoms as red spheres. So here's the first one, and over here is the second one. They both have the same charge, namely they are both positive. And because they have the same charge, they will experience a repulsive electrostatic force. They will repel each other. Fair enough. But that is not all. These atoms are also sharing a pair of electrons that are responsible for the covalent bond. This time, instead of a line between the two atoms, I am going to draw an electron cloud. My two electrons are somewhere in there, and all of the electrons are negatively charged. So for now, I'm just going to place a minus sign in the middle to represent that negative charge. And because all of the electrons have the same charge, they will experience a repulsive electrostatic force too. So all of the electrons are trying to be as far apart from each other as possible. What is keeping this molecule together? There is repulsion between the nuclei, and the electrons are not too happy about being close to each other either. All of that is true. But there is also an attractive force between the nuclei and the electrons. And in simplified terms, we could say that this attractive electrostatic force is stronger than the repulsive interactions. In summary, in case of ionic compounds, differently charged ions will experience an attractive electrostatic force. A positively charged cation will be attracted to a negatively charged anion. When it comes to covalent compounds, the situation is more dynamic, and both the repulsive and attractive electrostatic forces are at play. And we could say that overall, it is the attraction between the nuclei and the electrons that wins out. That is all for now, and I will see you on the flip side.